Hi, in this video we're looking at nested fractions, which are basically fractions within fractions. So that's a big no-no maths. If you want to do it, you want to rearrange as much as you can, so you have no nested fractions, no fractions within fractions. So here I could rearrange 1/2 over 3/4 as just 2/3. I'm going to see the best way to do that in this video here. So first, most basic case, one fraction over another fraction. So I'm going to go through basically the rule and also why it works. So we should know that any fraction is a word for saying division. Like 1/2 just means 1 divided by 2, which gives you 0.5. So this means 2/3 over or divided by 4/5. And we can write that down. And again, from years of dividing fractions, this is pretty straightforward to work out. We flip the second fraction upside down, and then we just multiply them together. So that'll give us 10 over 12, which can simplify down to 5 over 6. And that's basically how you write any sort of nested fraction as a simple fraction. If I was working that out, I wouldn't do all that maths. There's a slight sort of shortcut or basic rule you can remember. Anything you're dividing by on the bottom of the fraction will just go and join the top. Anything you divide by the top of the fraction will just go and join the bottom. So here I would do 5 times 2 is 10 over 3 times 4 is 12, which again simplifies down to 5 over 6. So let's go for a few examples using that rule. So with the shortcut again, anything in the bottom of the bottom half of the fraction goes to join the top. So 2 times 5 is 10. Anything in the bottom of the top fraction just goes and joins the bottom. So it's 10 over 7. Again, you can write that as a mixed number as 1 3/7. I'm just going to leave that as a top heavy fraction. Next, same idea here with some algebra thrown in. Again, the 7 goes to the top. So that's going to become 7x. These numbers join together and 2 times 2 gives you 4. Just two more basic ideas. Here there's no fraction on the top half of my fraction. Again, I have a fraction on the bottom though, so that number's going to join the top. 3x times 5 is going to be 15x, so I'm left with 15x over 4. Let's look at the same idea again, but here there's no fraction on the bottom. So that means nothing's joining that 7, however the 9 and the 2 do merge together to give us 7/18. Okay, those are the most basic ideas. What we're going to see now is when we have something more complicated. Okay, so here we can't quite do that because I don't have one fraction on the bottom part of this bigger fraction here. So we need to basically combine these two terms together by adding or subtracting algebraic fractions. This is pretty straightforward as far as that topic goes. First things first, we need to find a common denominator of these two things here. So x is basically just x over 1. So if we've got 1 and 3, we have a common denominator of 3. So all over 3. And here, if I want to have this over 3, I've got to times both sides by 3. So x over 1 is the same as 3x over 3. So now we can rewrite this as in this form here. Okay, so again, all of them there was I had x, I found a common denominator, which is everything over 3. Because if I added a 3 here, I must also add a 3 here. So now I've got to here. Same rule as the last example, couple examples back. I have this fraction is nested, so this 3 will go and join the top. So that'll simply give us 3 over 3x minus 2. Okay, slightly harder. Let's go for a few more examples like that. Okay, so here, the same setup. Before I can do anything, I want to write this bottom half as a single fraction. And again, I need to find a common denominator. That common denominator is going to be over 2. So 1, you should be fine with, is the same as 2 over 2. Now I can rewrite that as 4/7 over x minus 2 all over 2. And it's the same rules as before. This 7 will go and join here, and this 2 will come at the top. So 4 times 2 gives me 8. And if I'm timesing the bottom by 7, it's just going to be 7 brackets x minus 2. Again, you can expand that, but if you're not asked to, there's no real reason to. So you could write that as 8 over 7x minus 14, but both of them are correct. Unless you're told to expand and simplify, or expand it, then there's no real reason to do so. Okay, let's get slightly harder. So here we have a nested fraction. So if we look here, even in the bottom of my fraction, I've still got a nested fraction. What we're going to do here is we're going to sort out this bit first in blue. So let's just write that again. So that part is just 3 over 2/5. And that we can simplify. That's a very straightforward one. This 5 will come up to the top, so that will be 15 over 2. So we can now plug that in, we can rewrite that. So rather than 3 over 2/5, that is simply 15 over 2. And now it's the same rules as before. We're going to write this as one big fraction. So again, a common denominator of 2. That means 1 will become 2 over 2. So I've now got 2/3 over 17 over 2. And then same rules as before. This 2 jumps up with this 2 to give me a 4. These 3 and the 17 merge together, and 3 times 17 is 51. Okay, so if you've got a nested fraction, you just solve that annoying part first, which is here, and then pull it back into the equation or fraction above. Okay, I won't go through this, but yeah, these questions get fairly long and fairly complicated. Here's a fairly extreme case, but these tend to work out really nicely. So it turns out this massive humongous mess actually just equals 2. Okay, so feel free to work out if you want to, but yeah, they can go fairly crazy. We're going to keep it more basic level. I'm just going to finish up by going through an application of this. So we use these quite a lot when you're working out composite or compound functions. So here I'm going to work out gf of x using these two functions here. First step, we're going to replace this f of x with what we know it equals. So this now equals g brackets of 3 over 2 minus x. Now we need to plug that into g. The way this works, anywhere I see an x in here, I'm going to replace it by what's inside my brackets here. So in this case, 3 over 2 minus x. So that will equal 2 times, not x, but 3 over 2 minus x. All over, and then it's going to be 3 over 2 minus x plus 2. So yeah, I've copied this down. Anywhere I see an x, I plug this in instead. Now we need to simplify this down. We need to clean it up. First step, expand on the top is fairly straightforward. This 2 is basically 2 over 1, and then we times likely times fractions. So that will just be 6 over 2 minus x. On the bottom half, again, we need a common denominator. So let's do that fairly quickly. That's obviously going to be 2 minus x. If I add a 2 minus x here, I must also add a 2 minus x here. Okay, now we can group those together. So now I have 3 plus 2 brackets 2 minus x all over 2 minus x. Okay, we can see we can expand this bracket here. 2 times 2 is 4, and 2 times minus x is minus 2x. So now I've got 4 minus 2x, and 3 plus 4 gives me 7 here. Then we can see something's going to cancel out. So this 2 over 2 minus x is going to go here. This one's going to go here. So I'm now going to have 6 brackets 2 minus x all over 7 minus 2x, 2 minus x. And we should know from cancelling out that those 2 minus x's are going to cancel each other out. So I'm just left with 6 over 7 minus 2x. Okay, just go through one more example like that. So here I want f of x. So first step, replace f of x with what we know it equals, which in this case is x over 2 minus 3x. Then we're going to plug that straight in. So everywhere I see x over here, I want to write this fella here. So plugging that in, I'm going to get this. 2 minus 3 brackets this. Okay, now I need to simplify this big mess here. First step, I can expand this brackets. That's just 3 over 1, so that's just going to become 3x. Next, I need to find a common denominator for the bottom part of my fraction. We can see the common denominator here is just going to be 2 minus 3x. And if I add a 2 minus 3x to the bottom, I must also add a 2 minus 3x to the top. Okay, let's group those terms together. So this now is going to be x over 2 minus 3x, all over, I've got 2 brackets 2 minus 3x, minus 3x, all over 2 minus 3x. Okay, so we've got a humongous mess, but again, things will cancel out. That's kind of like a recurring theme for the more exam-style questions. Everything will like miraculously cancel out. Well, not everything, but most things. Next, I can expand this bracket here. That will just give me 4 minus 6x. I've now got 4 minus 6x minus 3x. That will give me 4 minus 9x. Same as before, this 2 minus 3x will go up here. This one will go down here. We hope to see that those two 2 minus 3x's are going to cancel out. Let's go through it anyway. We've got x times 2 minus 3x from down here. Where it's going to be these two terms times together. And we can write them both in brackets. Again, for these questions, there's no real need to expand anything out unless you are explicitly told to expand something out. The main reason is if we don't expand it out, we can see straight away that these two terms are going to cancel out. Which then gives us our final answer, x over 4 minus 9x. So I hope that made sense. Hope we covered all those steps. Again, just take it slow. And it combines a few different skills of nested fractions, using functions, and in this case also algebraic fractions. Hope that made sense, and thanks for listening.